Okay, guys, this is our third part of our lesson on odd, even, or neither. So this time we're going to be given a graph. So first of all, let's identify the function family. So this is the linear function. Linear functions make lines, and our parent linear function, remember, is y equals x. I need to know that, so I know my degree. Okay, so these have a degree of 1. So our choices are odd, because this is an odd number, or neither. So if we take a look at this graphically, if this function, if I can rotate it 180 degrees, will it look exactly the same as it does now? So if I rotate what's in quadrant 3 to quadrant 1, okay, it's going to look a little bit like this. And then what's in quadrant 3 to quadrant 1, yes. And then what's right here in quadrant 4, it's kind of going to look like this. And we can see this does not look like what our blue line looks like. With our original graph, it goes through 0, -1. When we rotate it or make it symmetrical about the origin, our y-intercept is going to bump up to +1. So this is neither. In this example, if we were to rotate our graph 180 degrees, what is in quadrant 2 here is going to look exactly what's in quadrant 4, and what's in quadrant 4 is going to rotate and look like what's in quadrant 2, and it's going to be odd. And now I'm going to pick 2 points to prove that. So if I pick, let's pick, here is this ordered pair, which is -1, -2, 1, and then this ordered pair is 2, -1. Remember, we're looking at the outputs of a positive and negative x, and these are opposite, so it is an odd function. Okay, this function family is our quadratic family, and the parent function is y equals x squared, so our degree is 2. So the two options for these is it's either going to be an even function or neither even nor odd. So we are going to see if they reflect across the y-axis, and we can see in this graph, this function, it is symmetrical about the y. If I were to fold along this y-axis, each point would correspond exactly to another one on left to right. The left side looks identical to the right side. So let's prove that. Here, let's look at these two ordered pairs. So we can see graphically it is even, but algebraically, so this is -3, 4, and this is, 1, 2. Let's fix that right quick. That's actually -2, 4, and this is 2, +4. So we're looking at seeing if these are the same or opposite or totally different. They are the same. These are the same. So we can say this is an even function. We can see here that if we were to fold the graph along this line, it would not be symmetrical. So this is neither. Let's take a look at this function family. This is the cubic family, and the parent function is y equals x cubed. 3 is odd, so our possibilities are odd or neither. And again, this is about rotating about the origin. So if I were to rotate this part of the graph around, it's going to look something like this. So what's in quadrant 1 is going to be in quadrant, it's going to look like this. So erase that. No big deal. So what's in quadrant 1, and it intersects at +2, is going to rotate to quadrant 3. And then this piece is going to look like this. And we can see these are not identical. They don't land on top of each other. So this is neither odd nor even. In this one, we could see what this part that's in quadrant 2 is going to look identical to what's in quadrant 4, and what's in quadrant 4 when rotated is going to look exactly what it does in quadrant 2. So if I rotated this halfway around, the graphs would look identical. So let's prove it with some points. So the outputs need to be opposite. And we can see here, those are indeed opposite. Okay, I have a couple more just little situations. Here we're given part of a function and we need to continue to make it even. So to be even, it has to be symmetrical about the y-axis. So I just like to start out and identify and list out our ordered pairs of each point. So we have -7, 5, and B is -5, 3. C is -3, 6. D is -2, 5. And our y-intercept is 0, 5. Now we're going to draw 5 more points to make this an even function. So I'm going to use the notation of prime, A prime, B prime, C prime, D prime, and E prime. So that apostrophe is called prime, Prime. It just means a transformation has occurred from the pre-image point. So when we're looking at odd or even functions, we know we have to look at the opposite x values, at the outcome of the opposite. So I'm going to go ahead and just get this ready. And 0 is neither odd nor even. Okay, we want this to be even. So all of the outputs have to be exactly the same. So this is 5, this is 3, 6, 5, and 5. Now we're going to plot these. So A prime, so it's reflected from here to over here, the same distance from our line of reflection, the y-axis. So we get A prime. And then B prime is 5, 3. C prime is 3, 6. D prime is 2, 5. And our y-intercept, E and E prime, are both the same point. And then let's connect them. And you can see, well, that was neater. You can see if we were to fold this along the y-axis, A and A prime would correspond, B and B prime, they would match up. Okay, let's do one last one. And this time, we're going to complete this to be an odd function. I'm going to go through and do the exact same process, but apply the rule to be an odd, which means our outputs need to be opposite in sign. So we have -7, 5, -5, 3, -3, 6, -2, 5, and 0, 5. And then we're going to have our transformations. So the little prime says these points have been transformed from the original, and the original points are always called the pre-image points. Get my commas ready. So we have to look at the opposite of our, so that's 7, 5, 3, 2, and 0. And this time, the outputs have to be opposite in sign. So all of these outputs, we're going to make them negative for our new points and then plot these. So A prime is 7, -5. B prime is 5, -3. C prime is 3, -6. D prime is 2, -5. And E prime is now 0, -5. And then we're going to connect those. And so if we were to rotate this around 180 degrees, what's in quadrant 2 is now in quadrant 4. It's rotated. So that makes this